Welcome to another edition of the Time Series Database Essentials webinar. I'm Joel Brass, Solutions Architect for TDengine, and today we'll be discussing low-code real-time alerts using Node-RED and TDengine for industrial monitoring. First, I'll talk a little bit about TDengine and tell you about that. Then we'll talk about Node-RED. Then I can show you a diagram of the solution we're going to be building today, and then I'll jump into a demo and show you how to set up real-time alerts with Node-RED and TDengine. So what is TDengine? It's a high-performance, scalable time series database for industrial IoT scenarios. We've built a zero-code data consolidation tool that works across industrial sites and many systems and protocols. We support OPC UA, OPC DA, and MQTT, among others. We've also built it on top of open source software and built an open ecosystem with easy integrations using standard interfaces like JDBC and ODBC to connect your app. There are also many client libraries for popular languages like Node.js and Python. TDengine is trusted by over 500 customers worldwide, including McDonald's, Siemens, Mingyang, and one of our newest customers, Sale ADV. TDengine has a rich ecosystem of data sources and visualization tools. On the left, we have a lot of the input sources that you can feed into TDengine, like MQTT, OPC UA that we had mentioned earlier, but it also works with standard SQL servers like PostgreSQL, Microsoft SQL Server. And on the visualization side, we support Grafana, Seek, Tableau, Power BI, and Perspective, among others. And we've now added in our newest official integration with Node-RED. So what is Node-RED? It's an open source low-code programming tool that was developed by IBM. It's designed for connecting hardware devices, APIs, and other online services together in a visual drag and drop flow editor that you access in a web browser. It's great for rapid IoT prototyping and building out automation workflows, and supports integration with technologies like MQTT, HTTP, and databases, just like TDengine. And there's also an extensible and large library of plugins, many community plugins, but we've built now an official plugin for TDengine in Node-RED. Why would you want to use the TDengine and Node-RED together? The easy method of connecting that we built in the plugin, the low-code drag and drop interface means you don't have to write complex code all the time, and it works in real time with the alerts being able to be filtered and transformed within Node-RED, which this allows you to go from deployment to idea very quickly. And so we have our new plugin that we've developed. It's the TDengine integration with Node-RED. It's available for download on GitHub. And I've also included our docs. We have a complete documentation site here. And in order to get running, if you were to want to install this and test it out on your own in your own Node-RED instance, you would use npm to install the package. You can install it using npm install Node-RED node TDengine, and you'll also have to install the TDengine WebSocket library, which is a dependency. But with these two packages is all you should need to get the TDengine integration going into your Node-RED. So here's an architecture diagram of what we're going to be building today in the demo. On the far right, you have the web browser and the user representing Node-RED, or next to Node-RED. And then inside of Node-RED, moving left, we have the Node-RED plugin, our client library, and then that is going to connect to TDengine via the TDengine Taos adapter, which is a component of TDengine. And the TDengine plugin adds 2 nodes to Node-RED. So it enables the TDengine operator, which allows you to read and write data from TDengine. It also adds a node for the TDengine consumer, which allows you to subscribe to topics from TDengine in a pub/sub type manner. All right, so now I will demo the solution. So as you can see, we have the TDengine Explorer here. This is the UI that is built into TDengine when you install it. Here we can see some information about it. And so the first thing I'm going to do is create our database. So actually, let me set some context here. Imagine that we're working at an energy company, traditional energy company that has been tasked with upgrading and modernizing their infrastructure. We'll call this company Acme Energy, and we're working as solutions engineers to create a new alerting system for Acme Energy. So what we'll do is create a database for our smart meters, our new smart meters that we're installing in our Acme Energy factory. So I've now created the database for our smart meters. If I refresh here, we can now see that. TDengine has a concept called a super table, which is a template for other tables. And this allows us to achieve the one table per device model that makes TDengine so fast. So now that I've created the database itself, I'm going to create my super table for the meters, the meter data, and I'll format this so we can take a look at it. So our S table will have 3 data fields and then the timestamp field for our time series data. So in time series data, you always need a timestamp. That is the index or backbone of our database data. And then we have 3 fields here, 3 numeric fields, 2 floats and 1 int. And then we're also going to tag the data records with group ID or location. And these are the tags that make the template of the super table. So I'll go ahead and run this. Actually, we just need to make sure that we specify the data here and run it. Great, now we've created our super table. And even within the super table, I'll now create child tables, one for each of the devices that we will be simulating. We have table smart meter 1, smart meter 2, using zero-based counting, and then we'll add smart meter 3. So now we've put in our 3 smart meters, and as we can see, they're now nested under meters. Now, what we need to do is create our devices in Node-RED. We're actually going to create these in Node-RED. Now, what we're looking at now is a finished solution, a bit of a finished solution in terms of what we'll be building. We're going to insert data through the devices. We'll aggregate data through queries, and then we'll build out the alerts eventually. So for the timestamp, we will inject, we use this. This is like a trigger. And for this, we're going to link this to a function that will become our device. We'll call this device 0. And in this device, we are going to create some data. So we're going to generate random values for our current voltage and phase, which will then be formatted into a message topic, which is the query, the SQL-like query that we're going to use to insert data into TDengine. So I will mark this done. And then I'm also going to write this into a TDengine node. We have our TDengine operator node type, which also will show up under the storage section. So when you install the TDengine plugin, under the storage section, it'll add 2 new node types. One is the operator, one is the consumer. And in the operator section, I now have to define and create a database. So if I were to add one here, it would ask me for the name and connection. For our example that we're using today, it's using the Docker Compose file that will be as in our time series essentials GitHub repo. And so you would put your connection string here. I have one configured that we can take a look at here, but the name is just TDengine, and we've set the URI to be our Docker, another Docker container running TDengine. And so now that I've selected this, I'll just call this TDengine database. And then I'm actually going to create 2 more devices, or duplicate this one and change the numbers here. So we know what this is, the second device, and now our third device. And then all 3 of these will go to our TDengine insert connection here, and we will be instigating them with our timestamp here that will repeat at an interval of every 1 second. It's going to send a signal to our queries to insert into the TDengine database. And if I hit deploy here, that's going to save the work. We can now see that it is connected. Actually, I'm going to add 2 more things. I'm going to add a debug node here at the end so we can see what is coming out. This is debug 10, and on this, we'll have it show the number of messages that it has received here. We'll deploy that. And so we can see every second 3 messages are being sent through TDengine. And if we go back into TDengine open source and say select star from smart meters, let's just go with D0. Let's just look at 1 device. And now I can see all the records that are being written here. I can also look across all of the smart meters using the super table query template. So that's here across meters. But if I just want 1 smart device, I can also put that in there as well. Now, in terms of notifications, we also want to be notified when we cross a certain threshold. So if any of these voltages or current go above a certain number, then that has to be reported by the Acme Energy team. So we're going to create a topic that the Acme Energy team can subscribe to. What we'll do is add a new topic. The topic can be based on a particular database or super table that you want to subscribe to, and all updates to that database or super table will be sent in the topic. I'm going to create a specific topic for our demo here. The topic will be called topic overload, which will select any time that a smart meter reading is above our thresholds of 25, where current is above 25 and voltage is above 230. That will trigger our alert. So let's go ahead and create that. So now we have our new topic overload here. So we'd also like to in node red. So now we've got our insert. This is our insert pipeline here. Now, the next thing we can do is aggregate the data through TDengine. And what we're going to do is send a query that'll allow us to see data in real time. So what we'll do here is inject a query into the topic. So the actual topic query is inserted as a part of the injection. And from here, we're going to run this to another TDengine operator node. And from here, we'll have to select our existing TDengine database. And from here, we'll put this to a debug node. And we can then deploy this, which is now injecting our query to aggregate or get average data across the different devices. We can see that by just looking at the selected nodes from here. We'll see that the results of the query, the average current, average voltage, and average phase are all being reported every time we inject the query here. So here's the query that was sent and the results. So now for the last thing that we'll do is build out our alerts. So the alerts will be in this section here. And this is where we use our TDengine consumer. So the TDengine consumer is what will subscribe to the alerts that are generated when we reach those thresholds. For the URI, I'm going to use the WebSocket URL of our TDengine container and point that to port 6041. I have to use a username and password. The default username and password for TDengine is root and Taos data. And for the topic, this is where we're going to go back to the topic name that we created. So this is topic overload. And for our offset, we'll set this to the latest. So it's always getting the latest messages that are sent in the queue. So here I'm going to hit done. And for the consumer, I'm going to route this to a debug so we can see the messages that are coming out. And let's just go ahead and deploy this so we can see how many alerts are being generated. And you can see that here also by showing the node status under message count. This will show us how many messages have been received by this debug node. We're now connected here. So anytime our randomly generated data reaches the threshold, and so we can see here that the number has already, consumer has already triggered twice. So now we need to format this into an email message. So we'll throw this into a function, and I'm going to just pull this from my finished code. So what we'll do is format this into an email message. So here we're just taking the message payload that contains the payload current and of the current record, and this is going to format this into a text string for email. I'll just call that format email message. And then from here, we're going to just go into a delay function. This will gate the messages so that we don't send every single message, as sometimes when you're in an alerting situation, that can end up sending a lot of messages. So we'll just set this to 1 email every 5 minutes so we don't spam the Acme engineers. And for extra messages, we'll go ahead and send those on a second Node-RED output so we can see them as well. So we're going to send this through our rate limit, which we're then going to send to an email node. And from here, we'll just send our overflow to a debug and set that to node status. Why don't we set the status to be the output, so we'll see the messages that it would send. And we're going to configure a node here to send an email to me. And this will come from TDengine alerts at gmail.com. Put in our super secret credentials. So once I deploy this, this should route the email message alerts via email. So we're connected. We have to wait and make sure that we have triggered the overflow. We can see over here in the critical alert has come out through the overflow message here, which should have triggered an email send. I'm going to go ahead and check my email. And we do have a new email here sent 0 minutes ago, with the body being our critical alert having been sent. So that is an overview of how to insert, aggregate, and alert in real time using Node-RED and TDengine. And so here is, you can scan this QR code that will take you directly to an article with all the same information. If you have any further questions about TDengine, please email us at the email on the screen. You can also try TDengine's cloud offering for free by getting a free trial at the TDengine cloud, and check out our open source offerings on GitHub. You can learn more about TDengine at our website, tdengine.com. Thank you very much.